Windows crashed. Once again. It's Windows. The streaming PC. Only because I have to use this goddamn freaking hardware with the streaming lights and all of that. Alright. Anyway. So, we're back. Let's see. Like, it's the funniest thing is, like, everyone is always like, oh, you know, Linux is so hard. I always have issues with Linux. Not one fucking time in the several years I have been streaming has a stream had an issue directly tied to Linux at a fundamental level. What I mean by that is, have we had issues with audio routing? Yes, but audio routing issues can happen on Mac, Windows, or Linux. That's not a Linux-specific thing. Whereas Windows, I've had this just like crash regularly when it's just doing its thing. Not streamer-specific stuff, it's just doing the thing. And then suddenly it just... Anyway. Let's see,
Typically getting...
Okay, good. I'm glad that I fixed my scripts issue, so it actually fixes the HDMI sync issue, so I don't have to fix the anymore. So we'll continue back in where we were.
8 cents per kilowatt hour exported, while the average grid price is around 35 cents. If that's going to be the case for your installation, you will likely wait longer until your solar system pays.
Hold on, I think we were a little bit further back before we cut out. Okay.
From the solar panels and converts it into AC, producing a slightly higher voltage than supplied from the outlet to allow current to flow back into the house. It does all of this using semiconductor magic, so no moving parts involved here aside from a safety relay. This slightly higher voltage produced by this grid synchronous generator is physically inviting your devices to use that power first, while the rest of the necessary power comes from the grid. Example, if you have the air conditioning running on a bright sunny day and your house consumes a total of 2,000 watts, having 1,200 watts of solar reduces what you draw from the grid and therefore what you have to pay for to just 800 watts. If your house just draws 1,000 watts, you feed 200 watts back into the grid. This excess power is then consumed by the nearest load, say your neighbor's house or the traffic light in front of your house. If you get something in return for the kilowatt hours fed into the grid, highly depends on...
Audio's going weird. What's wrong with the audio? Anyone having audio issues? Or is it the frickin' stream box being stupid again?
your utility provider. They may offer net...
Audio is fluctuating. Hold on. Let me unplug it and plug it back in. That seems to be our #1 fix. Okay, hold on. The script should be picking up on it any second. Okay. CD source NVIDIA. Hold on. Let me fix this. NVIDIA capture card. LS. And then... where was it? God damn it. Hold on. Nope. Hold on. Just trying to remember where I put that stupid option. Oh, there we are. Alright, so we're gonna need to go to... Okay. And we need to run that script to... Where the hell is it? Oh. It's a hidden folder. CD screen layout, and then... Apply layout. And we should be back. There we go. Should be setting all the audio back up. Couldn't remember what the where I put the damn file for the reset to get that layout back. All right. Let's see. How is this?
Metering, which means
All right. Let me know how this works now.
what you overproduced from what you consumed, reducing your bill even if the generated power wasn't consumed in your home at the time of production. This is the best case scenario for your wallet because 100% of what you generate goes back into your pocket, drastically reducing the time it takes for the plugin system to pay for itself. However, different models are possible. You could either get a fraction of each kilowatt hour produced as a credit or simply no payment at all. Here in Germany, we are typically getting around 8 cents per kilowatt hour exported.
So that was an NVIDIA issue that has to do with the handshake. There seems to be some issue with the HDMI handshaking. I keep having to fix issues with that. But my script does that as part of it.
While the average grid price is around 35 cents.
That's in GitHub if you want to look at it, by the way.
You will likely wait longer until your solar system pays.
But it only works on X11, not Wayland.
By running energy-intensive loads like your washer or dryer during sunny hours, so to maximize your self-consumption. In any case, make sure to speak to your utility provider to learn what their rules are and if you already have the right electricity meter before buying anything. Because if not, your exports to the grid might be counted as import and jack up your bill instead of lowering it. What you need is a bidirectional meter that measures import and export separately. Now, looking at those open prongs on the inverter cable, you might rightfully ask, is this actually safe or can I get an electric shock from the plug once the solar panels are connected to the inverter? And the answer is yes, this is quite...
So that's a good thing to know about, that you will need a bi-directional meter. So before you even get into this, you should probably ask your utility companies about that. Don't know if there's a cost associated with that, so your mileage may vary.
safe if you have a properly tested and certified model. Modern grid-tie microinverters feature a safety system called anti-islanding that constantly measures grid resistance, voltage, and frequency. Once you unplug the inverter, it stops production and disconnects its energized circuits from the output within milliseconds, making it safe to touch almost immediately. But this also means that a plug-in solar system does not offer backup power in case of a power outage. You even have to disconnect it when running a generator or power station because an inverter backfeeding can cause damage to them. While the inverter is usually a very safe part in the system, the state of your electrical wiring and where exactly you plug in the solar system is definitely something you want to look into. That is because having a plug-in solar system combined with other loads on the same breaker carries the real risk of overloading that circuit.
Yep.
In most cases, one breaker serves multiple outlets that are daisy-chained along a cable. A typical circuit in North America uses 14-gauge cable and is protected by a 50-amp breaker. So if you overload...
I'm bougie. 12 gauge, 20 amps. When I run new circuits, that's what I do. Why bother? It's only a couple bucks more a run. You get so many more watts. Like, to give you an idea. So, if you aren't familiar, in the United States, so 120 volts times 15 amps with sustained load. So that's your sustained load. 1440 watts is generally what you want sustained. So if you get 20 times that times, yeah, you get about 480 more watts on the same breaker.
By a few amps usually trips within an hour, stopping that cable from overheating and possibly causing a fire. If you add an electric
Wait, what did he say?
cable and is protected by a 15 amp breaker, so if you overload it by a few amps, usually trips within an hour, stopping that cable from overheating and possibly causing a fire. If you
Did he say
usually trips within an hour, stopping that cable from overheating and possibly causing a fire. If you
So here's the thing. Circuit breakers generally, they may not always trip under sustained loads like that. So they're great at, like, yeah.
add an electricity generator like a solar system to that circuit, you increase the circuit's capacity by what the generator can produce. So a 1200 watt system, which is 10 amps at 120 volts, will increase the maximum continuous current to 25 amps within that 15 amp circuit once the sun shines bright. That is already too much to safely run on a 14 gauge cable for longer, especially if it runs in insulated walls. But since breakers are usually designed to cut power if their rating is exceeded by 35% for over an hour, this puts the maximum current at 30 amps, at least temporarily, making the cable the weakest element in the circuit instead of the breaker. That in turn will make it a fire hazard. You might argue that the loads you have plugged in don't even draw that much power, but you also have to take into account electrical faults where the current is no longer limited by the normal functioning of the device, and a delayed breaker can make the difference between a little bit of white smoke and a full-blown house fire. To get to the point, a plug-in solar system should be connected to a circuit with as few outlets as possible, so that solar energy has to go through your electrical panel and another breaker to reach your devices. For example, if you have an outlet in your garden shed or a dedicated one in your garage that has its own breaker, those are great to plug in your little power plant. If in doubt, speak to your favorite electrician to make sure everything is safe. If they suggest installing a dedicated solar input, it's probably worth the money. Alright, let's talk about panel placement. Just because we Germans like to call it Balkon,
That's not actually too bad of an idea to just have a dedicated outlet just for that as an intake. Actually, where I think I was planning on running the wires in, it would make total sense to just knock it out there.
in fact, that does not mean that it needs to be put exactly there. We don't stick to that either. Generally, every place that A has enough space for panels, B can carry their weight, that's around 50 pounds per panel, and C is exposed to the sun for most of the day will do. That can also be your lawn, your shed, or even your roof. Just make sure to ask your local administration which one of these places might require a building permit to add solar to. And if you rent, speak to your landlord first. If your utility provider offers net metering or if you work from home, placing your panels facing south makes the most sense to get the most power during the day. If you want to maximize self-consumption and are usually out of the house during the day, an east-west installation where you position half the panels facing east and the other half facing west will get you the most solar power in the morning and in the afternoon. Now, I can already hear those with prior solar experience say that you can't do that because all panels need to be pointed in the same direction for it to be efficient, and that is true for systems where panels are wired in series and then connected to a single input inverter. But the microinverters used in plug-in solar systems typically have one input per panel and either optimize each panel separately or in groups of two, so you won't waste power in configurations like that. Usually, the datasheet of the inverter tells you which input belongs to which tracker, but a lot of modern microinverters feature one tracker per input. One more thing, the tilt angle. Basically, how steep the panel is leaning relative to the ground. As a simple rule of thumb, a good all-around range in most of the US and Canada is about 20 to 50 degrees. Closer to 30 degrees tends to favor summer production.
20 to 50 degrees. That's a pretty, that's a good amount of difference there. That's 30 degrees of difference there.
While 40 to 50 degrees usually does better in the winter and helps snow slide off. So in colder, snowier areas, going steeper often makes more sense. You can mount panels flat, but that will drastically reduce production in fall, spring, and winter. Plus, if you have trees nearby, dirt will likely accumulate.
0 to 360 degrees will work. Exactly.
What does a plug-in solar system actually cost when you buy it in the US right now? You can get plug-in suitable microinverters with 1200 watts of output power from EcoFlow and NAP, and both set you back around $300 US.
Oh.
Non-affiliated links are in the description. EcoFlow are the only ones currently offering a set with both a microinverter and 2 or 4 rigid panels, costing you $10.99 or $18.99 plus taxes and shipping.
That's actually not bad. Let me see these. Hold on. What is it? EcoFlow. Just curious. Because I would need a power station and inverters, so... What are they? Products... Hold on. Go away. Alright, let's see. Solar panels... Mountable solar panels... Where do they have the, are they just in there as the option inside for the inverter? Let me see, home battery systems. EcoFlow Power Insight, Smart Home Panel. Where is this little guy? Streams. Oh, there we are. The Stream Micro Inverter. So they have these. So it's 300 for this guy. And then, what was it? You can plug up to 4 panels, I think, in these. Is what they said.
Right now, you can only order it to addresses in Utah. You can...
No!
And plus taxes and shipping. And right now, you can only order it to addresses in Utah.
Wait, you really only can order it to addresses in Utah? Well, fuck you!
Can save a lot of money by bringing your own panels, ideally by finding a solar shop locally where they typically sell for $100.
There, Bubble. Yeah, pretty much. Get a friend who lives in Utah and have them mail it to you. Problem is, I don't have any friends in Utah. I asked how old are you when you started coding? I started doing like bash scripting, not really like proper coding, I guess, in my teens. I know more people in Wyoming than Utah. Yeah. Everyone that I know that is really awesome from Utah left Utah. Nobody awesome wants to stay in Utah.
$50 to $300, depending on make, model, and output power. If you are interested in that, let us know in the comments below, and we will do another video in English covering all the technical details on how to correctly match the panel specs with the inverter. Since choosing the right mount highly depends on your situation, they are usually not included with sets like the one by EcoFlow. But panels used for plug-in solar and full-scale installations are alike, which makes finding mounts easy. Panels typically have more or less standardized 8mm mounting holes, and their frames are between 30 and 40 millimeters thick. So you can just ask a local solar installer if they can sell
recommendations for RCA capture cards. I don't know about RCA, but
mounts that can be used for wall or roof drilling free stands are also
was it
your yard or carport. And of course,
shoot,
sets for your
was it Black Magic? I think it is. Makes the some of the better capture cards for
all in all, the whole endeavor will
Linux.
cost roughly $1,300 to $2,300 before taxes if you go with EcoFlow, and $1,000 to $1,700 if you bring your own panels. I know that is certainly more than the few $100s I mentioned in the beginning, but once this gains traction, prices will drop significantly and more competition will hit the market. That's what happened here in Germany, and I'm sure it's going to happen in North America. For reference, a typical 800-watt solar set with everything that you need costs you roughly
Kale
400
Thifari
euros
is
around.
now chilling in the lab.
Jeez.
$70 US, including taxes. Also, I am aware that doing all of this by
Thank you for the follow.
can sound pretty complicated if you are not in tech, especially when it's explained by a fast-talking German, a la the Wood Fairy. But believe me, once you've gotten into the matter, this is pretty easy stuff and can get quite addicting. I actually like to call this Lego for adults because it's that easy once you've gotten the hang of it. Not to say that adults shouldn't play with actual Lego, that's absolutely valid. Whatever, you know what I mean. Anyway, I hope you enjoyed this video. Please like it if you did. If you have questions, comment them down below and we will try our best to answer them. Thank you for watching und auf Wiedersehen.
Alright, what was the next video? So we got the YY. And, oh. I guess Vampire had some more TikToks they shared in here.
Man tried driving his Tesla Cybertruck across a lake like it was a boat.
Oh, I heard about this! The dude was like trying to prove how his like Cybertruck was so amazing, and then like dude like totally gave himself a serious L, because not only did the Cybertruck like completely just like shit itself, but he got a ticket for it and it got stuck.
To test Tesla's so-called Wade mode. And now he's threatening to sue the...
Oh, the Wade mode. That's right. That was what it was about. Something about, like, it could work in the water. Because if you remember, there were some Chinese EVs. Was it the Yangwang or something like that? A really, really nice EV that one of their claims to fame is you can literally drive it in the water kind of like a boat. Well, not like a boat, but, you know, like, it can float. And that's what Tesla is kind of, like, competing against, and Tesla's a joke of a company, really, realistically. I know a lot of the evangelicals are going to be out there like, no, you're the greatest! You're the greatest! But really, come on. This is a garbage can.
company after the truck immediately failed. According to police in Grapevine, Texas, officers responded to reports of a Cybertruck submerged in a lake and discovered that the driver, Jimmy Jack McDaniel, allegedly drove the vehicle into the water on purpose to see if Tesla's feature actually worked. After the truck became stuck,
couldn't you have, like, done this in, like, a small pond? Or, like, something, like, less crazy. But then again, if you're going and buying a Tesla truck like this, and spending money like this, and, you know, making excuses for how amazing this truck is, you're not really all that smart, are you? Explain what a mother means when she states German cockroaches. It's just a type of cockroach. Alright, what's next? Rose the Robot rage quits after subbing in for Jim on live stream. What is this? Was this an AI video? This has got to be an AI video. That feels like an AI generated video. Yeah, I don't know how I'm supposed to feel about that. Alright, let's see. Next video. 2-Bit Da Vinci. Testing the first mass-produced solid-state battery hands-on. Whatever happened to the Parkinson's bottle? We tested it. I mean, I was just testing it out. I wasn't the designer of it. We as a community tested it out. Forget the other guy's name. He was working on it 2 different paths. One was the community to have an open sourced version. There are open source versions out there. And then there was to be a commercialized version that was affordable. And my understanding is that part has also been getting tackled or that. It's been a few years, but yeah, all I did was I just led testing efforts and fundraised for supplies and sent out a bunch of money for, you know, people that were 3D printing so they could get the 3D printing supplies and beds being replaced and stuff like that for the 3D printers. That was all. So.
I just drove a nail through a charged battery, took a blowtorch to its electrolytes. I tried to melt its ceramic separator, and I even cut one in half with a pair of scissors, and nothing happened. It's not just another safer solid-state battery. It's the world's first high energy density battery that doesn't undergo thermal runaway.
That's freaking awesome.
That has been deeply focused on solid-state battery development for over 20 years, with more than 1,000 patents. And it's not just their products that are ahead of the industry. Their manufacturing capability is too. Since 2013, Prologium has delivered more than 2.4 million battery cells across a wide range of applications, from drones, wearables, semiconductors, and even large-scale EV cells as far back as 2016. And now they're scaling up even further into markets like AI, robotics, maritime, defense, and aerospace. When we flew out to Taiwan and partnered with Prologium, we asked for full access. Every test, every floor, every question. And they said yes to all of it. If you only watch one solid-state battery video this year, make it this one. I'm Ricky, and
This is a little bit longer of a video, but we'll allow it. This will be the last video of the night, just so you know.
Here we go. I've toured 3 battery factories, and I was never allowed to film anything. Prologium let me film everything. So in this video, to keep it
That's
clear,
amazing.
each one of their lines.
When a company, like, lets you, like, just see everything, it's like, yeah, that's a company that has nothing to hide.
Starting with their sheet-by-sheet production line for samples, second their roll-to-roll pilot line, and finally their roll-to-roll giga-level production line that they've started in 2024. First, we got to define what a solid-state battery actually is, because right now there actually isn't a great definition. But in May of 2025, the Chinese Society of Automotive Engineers released the first official solid-state battery test. And in July here of 2026, the Chinese national regulators are going to actually incorporate an even stricter version into law. Here's how it works. Charge a battery, cut a small hole in the case.
So, am I correct in understanding that China is ahead of the USA and the West on solid-state battery technology? And if that is correct, doesn't this cement my point and how I've been saying that the U.S. embargoing and sanctioning China and choosing to not compete with China has left us at a disadvantage because we're competing with the rest of the world except China, and China's competing with the rest of the world, including the USA and everybody else. So we're blind to the Chinese markets and what's going on there. So we're being caught with our pants down. Like, the fact that you have all these evangelicals that are getting on their knees so ecstatic about Tesla as the greatest thing since sliced bread and can't even look seriously at how far ahead a lot of the Chinese EVs are in price, technology, and capability. It's just, it blows my mind just how far people have their heads in the sand on this situation.
And flip it upside down. If a single drop
The USA can compete. They just choose not to compete, and we completely, shoot ourselves in the foot every time.
of liquid leaks out, it's instantly disqualified.
You're back. What happened? Oh, the Windows machine that runs a stream crashed.
Celsius for 6 hours and gets weighed before and after.
There's a 2 PC setup running the stream.
Carbonate solvents that evaporate. So 6 hours of pulling vacuum at 120 degrees Celsius causes significant weight loss. A solid electrolyte loses less than 0.1% of its weight. To pass China's 2026 national standard, your cell has to lose less than 0.5%. Anything more, and you're classified as a hybrid. Prologium's Gen 3 cells pass with an average weight loss of just 0.05%.
Jeez!
Order of magnitude below the threshold. Lithium-ion batteries are basically two chemical volcanoes pressed up against each other. The cathode side wants to release oxygen at high temperatures, and the anode wants to combust in any oxygen that it sees. Between them sits a flammable liquid electrolyte and a piece of plastic film about 20 microns thick called the separator. That plastic melts around 130 degrees Celsius, and thermal runaway, the chain reaction that turns a normal battery into a fire, kicks off around 150 degrees Celsius. This is the biggest danger of batteries, and what solid-state batteries are trying to engineer out. Replace the flammable liquid with a solid material, and replace the meltable plastic with a high-temperature resistant ceramic. It sounds simple, but it's anything but.
We've been trying to go after this for decades.
40 years. No matter what kind of the electrolyte you use, the liquid or solid one, the industry has still no truly established and no similar runaway cell chemistry system under the standard R test.
The reason is that solid state has 4 problems, not one: safety, conductivity, pressure, and scale. The problems fight each other. The chemistry that makes a battery safer usually makes it slower to charge. The chemistry that makes it faster usually requires extreme pressure to keep the cell from falling apart. Engineering around the pressure and your manufacturing lines slow to a crawl. Pick any solid-state company on Earth, and they'll tell you they've solved maybe 1 or 2 of these problems. Prologium says they've solved all 4 at gigawatt hour per year scale.
Jeez.
Shipping today. Prologium was founded in 2006 in Taiwan, and on day 1,
And they've been shipping for like a decade or so.
stuck with for 20 years. Skip plastic separators entirely and build everything around a ceramic one. Now we're inside what feels almost like a museum. This is a sample production line that was commissioned back in 2013, and it's still in use today for engineering validation and testing. It's a great reminder that
Wow, they've been doing this for
overnight, and it's not
since 2013.
It's built step by step, layer by layer, over time.
They've sealed the top, you saw that. They sealed one side, and so that's sealed, and this is open right here. So in this machine, they're gonna apply vacuum to, I think it's under like 95 megapascals of pressure to pull out all the air and vacuum it, and then seal this final one. This is the manual process of how they do it, which is amazing because you can actually see it, take a minute and look at it. There are automated lines that we're gonna see next. You can't even get close to it. So you can't really get hands-on with this. This is really
Jeez.
cool to see.
Every cell they've ever shipped in any generation has used a ceramic separator. No PP or PE plastic ever.
For the day 1, we have already considered not only the battery performance, but also how to achieve the real
We could make that into like basically any size or form.
the electro and ceramic separators and the cell design optimizations to manufacturing and process and also equipment.
By 2013, they were already shipping commercial cells with ceramic separators at a time when most competitors were
So they've been shipping these since 2013. How come we've not heard of these?
17. And that pilot line still runs today at 40 megawatt hours a year. Today, they've shipped over 2.4 million cells in drones, wearables, semiconductors, and large EV cells, and they're already in production with multiple OEMs. In 2024,
Oh, so they're scaling up.
first gigascale solid-state battery factory in Taoke, Taiwan, a facility I actually got to walk around and observe for hours.
That's moving. It looks stationary, right?
I can drop the link. Hold on.
Laminar flow.
And now they're ramping up their newest cell, a Gen 4 design with a 100% silicon composite anode and the highest energy density ever verified by independent lab testing. And it's a cell that we got to test, measure, and torture for the rest of this video. So let's get into the 4 problems and how Prologium solves them one at a time. Let's start with the safety problem because it's probably the most important for consumer trust. When a lithium-ion battery overheats, 3 things happen at once. First, the charged cathode, usually a nickel cobalt manganese oxide or NCM, starts releasing oxygen at around 150 degrees Celsius. Second, the oxygen reacts with the charged anode, which is essentially a reservoir of lithium energy that desperately wants to combust. Third, the flammable liquid electrolyte between them ignites and fuels the whole thing. Once it
What the hell are you going on about, like, white supremacy conversation? We're literally talking about solid-state batteries!
starts, you can't really stop it. The cell
I swear sometimes people on different platforms just need to just...
heats itself, vents and burns until everything reactive inside is gone.
It was just somebody that, on a different platform.
In an EV
I'm simulcast to 4 different platforms.
Conventional batteries fight this with one tool. that thin plastic separator that physically keeps the cathode and anode apart. The problem is that plastic melts at 130 degrees C, and thermal runaway kicks in at 150.
I'm on Twitch, Kick, YouTube, and TikTok.
Prologium's answer is what founder Vincent Yang calls triple safety, 3 independent defenses, each backing up the next. Safety 1 is the ceramic separator.
Okay.
It's an oxide ceramic. It's hard, mechanically tough, and stable up to Safety 2 is the all inorganic.
What do I have the most viewers on?
Solvents and no flammable organic chemistry of any kind. It's non-flammable not because it's well contained, but because the material itself can't burn. Number 3 is ASM, or the active safety mechanism. This part is pretty genius. Built directly into
TikTok, but not by much. And then YouTube and Twitch are doing all right.
Runaway can even start, and chemically dismantles the charged cathode and anode, converting them into.
Wait, let me hear that part again.
This part is pretty not because it's well contained, but because
I didn't hear the 3 parts.
Safety 2 is the all inorganic electrolyte. No carbon.
So the ceramic, an inorganic electrolyte.
It's non-flammable not because it's well contained, but because the material itself can't burn.
Wow.
Is ASM, or the active safety mechanism. This part is pretty genius. Built directly into the electrolyte is a chemistry that activates at around 125 degrees Celsius before a runaway can even start, and chemically dismantles the charged cathode and anode, converting them into low energy compounds. The cell goes permanently dead, and it doesn't burn. It doesn't really even get particularly warm. Prologium's Gen 4 cell is the first lithium battery.
Hold up. So it doesn't have thermal runaway, it just dies. What? That's neat.
In 40 years to pass the gold standard ARC, or accelerating rate
Is this AI? No, it's not AI, and y'all need to stop thinking everything is AI. Just because somebody can actually read a script does not mean it's AI. I mean, for fuck's sake, I have videos of mine. I've, clipped of my own YouTube videos, and people are like, oh, this is AI. Oh, you had AI write this script. And I'm like, what? Because I can form sentences together? I happen to be AI?
Perimetry test without going into thermal runaway. And the result.
What, the graph that's AI? I don't know.
Independently third-party tested. In Prologium's reliability lab at their HQ, I watched as they tested 5 different ways to absolutely destroy a battery. First was the oven test. A live cell goes into an industrial oven that ramps up to 280 degrees C, almost twice the temperature where a conventional battery would already be on fire.
Hold up. Let me make sure I understand this right. They are testing a battery at 280 degrees Celsius.
In Prologium's reliability lab at their HQ, I watched as they tested 5 different ways to absolutely destroy a battery. First was the oven test. A live cell goes into an industrial oven that ramps up to 280 degrees C, almost twice the temperature where a conventional battery would already be on fire.
I can feel the heat.
Damn.
Even through all that, look at the level of insulation, how thick that wall is. This is what 280 degrees Celsius does after over an hour. So it's fully charged, set into the oven at 280. And this is just an example of the safety of the cell. So no thermal runaway events, nothing happened.
Wow.
All safe.
I mean, it looks destroyed, but
it came out structurally intact. The damage was irreversible, but the cell was completely stable.
By far one of the coolest tests you'll see. This is a nail penetration test on a solid-state battery. Let's see how it fares. Nothing happened with what you want to see, but the orange line here is voltage. It started nice and steady. As soon as the nail punctured it, the voltage dropped. That's what you want to see, what you'd expect, because there's no voltage potential anymore. The 2 ends are now shorted. Now if you look at the nail puncture test, you'll see 2 thermocouples coming off of it. That's the 2 different temperatures here. The red is the nail temp, that the thermocouple on the nail, it's rising, and the blue is the cell temp. That's the thermocouple on the cell, also rising. Exactly what you'd want to see if you had a puncture. And the battery is safe. Goodbye. forever. Here we go.
That's ridiculous.
The external short circuit test. A direct dead short between the terminals at a full state of charge. A conventional lithium ion at 100% state of charge would go very wrong within seconds. Now,
Yeah, you do that. That is like, oh, like, don't ever short out a lithium battery. I've done it. It's not fun.
next, we tested the electrolytes. Side by side, a beaker of conventional carbonate-based liquid electrolyte and a sample of Prologium superfluidized electrolyte. We hit both with a propane torch. The conventional electrolyte ignited pretty much instantly.
Right.
Burned vigorously. Prologiums didn't ignite and didn't smoke. Next, we
Just kind of
tested the
boiled.
ceramic separator against a conventional separator. I used the same propane torch, and you can see immediately the difference between a ceramic separator and a PP polypropylene or PE polyethylene separator. It didn't melt, it didn't shrink, and it didn't ignite. And after we pulled the flame away, the separator was still electrically insulating.
Mission hacker guys. I think I actually see his videos.
I cut a cell in half.
Part of the challenge with ceramic separators is brittleness, right? So things like this, even, you know, hitting it like this,
Right, percussive shock.
issues. It could cause a short inside of the battery.
Right, because ceramic is very strong, but it's brittle. So, like, if you ever get a ceramic knife, they can have a really, really strong edge, but you can break that edge really easily. So, yeah. Let's see.
It's working without any problems.
Shit!
Now, I can just cut it, right? This is, this is one of the most wrong feeling things I think I've ever done. But I'm gonna cut this cell. You ready? Here we go.
What? Like you just saw that. Like, look at that. Look at that. It just stops for a second. Look at that. Like, it shorts. It works again. Like, you may have just have the capacity of the battery there, but it's still working. Like, not only did he not have thermal runaway, not only is this safer, but it kept operating. That freaking blows my mind. When can we get this battery tech? Like, I need this shit now. Like, I need that yesterday. I need that in my Tough book. I need that in my Meshtastics. I need that in my phones. I need that in everything. Goodbye, lithium ion.
I just cut that cell apart, and with what's left, it's still working.
Very interesting.
That's the part. That's the part that blows my mind the most. Is like, okay, cool. It's already mind blowing that like we don't have thermal runaway or anything. But I mean, that alone is super impressive. But it keeps working.
Down. You can see that the LED goes out.
What are you talking about? New solid state battery technology. So that's residual power left over. My laptop charger's back. Does that when I unplug? No. That's not residual power. That is the power. That is the battery. When you're talking about your laptop charger, so your laptop charger has capacitors in there that it's storing some power inside of there as part of the process to filter and clean that power going into your laptop. Capacitors, by the virtue of how they operate, store power. A battery stores power too, but think of a capacitor more as like a high pressure tank, like an air compressor. You can put it under a lot of pressure and shoot it out really fast, but it can't store a lot. But a battery is like a massive tank, but it can't shoot it out in massive amounts of pressure. It's more of a steady stream.
The metal in the scissors shorts the two electrodes, resulting in a voltage potential between the two dropping to zero. But once I finish the cut and the scissors are removed, the short is removed, and the cell recovers and the light comes back on. That's a clean cut through both current collectors, anode, cathode, and separator. And other than losing half its capacity, the cell kept on going.
Yep.
And most
That's what I was saying.
nothing leaked. That solves problem one.
Yep.
But safety alone doesn't sell batteries. If it takes 4 hours to charge or costs 4 times as much, no one's going to buy it.
This is true.
That's to problem 2, conductivity. How fast lithium ions can actually move through the electrolyte. It's the second hard problem, and it's proven to be quite difficult for solid-state batteries. In a normal liquid electrolyte battery, lithium ions and their negatively charged counter ions both move freely through the liquid. But under heavy current, the two species start drifting apart, building concentration gradients that fight effective transport. Battery engineers call this concentration polarization, and it's a big reason your phone charges fast to 20% and slows to a crawl at 80. Conventional solid-state batteries fix concentration polarization by locking the negative ions into a rigid crystal lattice. Now the lithium moves, but has to hop between fixed atomic sites, and every hop costs activation energy. The result is dramatically lower conductivity, which means painfully slow charging for the end product. Their electrolyte is neither.
It is not
Wait,
a
what?
liquid and not the rigid traditional solid-state one. It is the third type of the electrolyte created through the human innovations.
They call it a superfluidized, all-inorganic
What the shit?
electrolyte. And as the name suggests, it's an all-inorganic solid electrolyte that has been superfluidized, exhibiting non-Newtonian behavior. The material has the consistency of soft pudding, and when subjected to higher
I was wondering why there was pudding.
the
Pudding.
technical term is shear thinning.
Progen Technologies is designed to be combined the strengths of the both of systems. Our superfluidization of inorganic solid-state electrolyte can deliver high ionic conductivity like the liquid electrolyte, high lithium-ion transportation efficiency, and low polarization like the solid-state electrolyte.
Prologium's founder, Vincent Yang's analogy was a relay race. The lithium ion never has to travel far through the electrolyte. It hands off to its neighbor, who hands off to the next, in short hops through a coordination
The shit?
dynamically reconfigures around it. The negatively charged
That is...
ions are everywhere around it, but they don't run laps. They just step aside locally to let the lithium through.
The whole point of the electrolyte is to conduct, right? So this is measuring the conductivity for the traditional battery electrolyte, and this is the palladium electrolyte over here. And if we
How's it compare with the output of regular lithium-ion batteries?
this becomes 4
That's a good question. I'm guessing they'll talk about that.
order of magnitude, over 10 times higher conductivity for
Do
this.
you have any experience in electric engineering? Mostly just small personal projects.
But the electrolyte alone isn't enough. Lithium still has to cross from the electrode to the electrolyte itself. And at that boundary, most solid-state cells completely fall apart. Prologium's answer is a thin engineered coating on each electrode they call IDL, short for ion diffusion layer. Its only job is shepherding lithium across the boundary without resistance, cycle after cycle. Solid-state batteries fail at this interface. The interface we've always talked about is the trickiest part when it comes to a full solid-state battery.
You want to combine your cybersec knowledge with electrics, but I'm a newbie at all electric stuff. There's quite a few people that do that in cybersecurity.
Temperature.
We do that a lot in amateur radio as well.
This is certified on-site by an agent from SGS, the Swiss certification body. SGS didn't have the equipment for this kind of test, so they sent a representative to verify Prologium's own measurement. Still independent third-party validation, just done a little differently than usual. About 5 times faster than the best liquid electrolyte, and
Damn!
faster than any conventional solid. Even at negative 20 degrees Celsius, it still measures 12.5 millisiemens per centimeter, retaining over 95% of its capacity in cold weather, where most batteries lose 30 to 40%. So then this trend
What the shit?
5 to 80% fast charge in around 6
Is this like a magic battery that was sold in a pack of double A's next to Jack's Magic Beans for his beanstalk?
minutes. And if you're keeping score at home, high conductivity, full transference, low polarization, cold temperature performance, that's a list of properties no liquid and no solid has ever delivered together. Which brings us to problem number 3. The other major
Tesla would go insane with this. Nah. BYD and Xiaomi would go really insane with that. Tesla's so behind the times in terms of EV tech. It's not even funny. Like, anyone that really thinks that they're all that really has not seen how far ahead China actually is with EVs, and I've seen them firsthand when I was in Europe.
Type of solid-state battery electrolytes being pursued is the family of sulfide.
Who else can afford the research funding? BYD? Xiaomi? Look into those companies. In fact, Tesla, in some of their cars, uses BYD's batteries.
Which offer high conductivity comparable to liquid, but with one massive engineering catch. According to a 2026 paper in the journal Joule, sulfide solid-state cells need an operating pressure of about 800 atmospheres. It's about 12,000 psi, the kind of pressure you'd find 8 kilometers underwater.
It's a lot of pressure.
12,000 atmospheres just to manufacture them. Why? Because sulfide particles expand and shrink during every charge and discharge cycle. They lose contact with each other, and the only way to keep them touching is to mechanically compress the cell from the outside forever for the rest of the life of the battery. Now this means higher mass, higher cost, and you can't even use them on phones or drones because the pressure system alone would weigh more than the battery itself. Palladium superfluidized electrolyte handles this completely differently. The gel texture network self-maintains contact through every charge cycle without permanent external compression. But there's a nuance worth getting right here. Every brand new battery, solid state or not, goes through a process called formation. It's the first few controlled charge cycles right after the cell is built, where the chemistry settles into its final working geometry. The active materials expand in place for the first time, and the internal interfaces lock in. Think of it like breaking in a new pair of shoes. But once that formation finishes, typically a handful of cycles, that pressure comes off and the cell operates at exactly 1 atmosphere for the rest of its life. A gentle squeeze during break-in versus 800 atmospheres forever.
So is that like, do they do the break-in, or is it like you get your battery and then you get like an instruction like you do when you buy a car and it's like, here's your break-in instructions for your engine?
It results.
Doesn't Polestar use some BYD batteries too? I think so. BYD is a pretty well-known battery company. They started with cell phone batteries, if I'm not mistaken.
Lighter, safer, and cheaper path. And that unlocks the real market potential of next-generation batteries. Which brings us to the fourth problem, and the one that actually killed most solid-state batteries that I've ever tried to ship. And that would be manufacturing. Here's the dirty secret of solid-state batteries that no one talks about. The chemistry has actually kind of been solved for a while now. The hard part, the part that is really hard to get right, is how to take that idea and produce it on a massive line at scale. How do you mass produce a brittle ceramic separator the size of a phone screen on a moving production line without cracking it? There are 2 competing approaches. Most American and European competitors use a process called sintering. You heat ceramic powder to over 1100 degrees Celsius until...
This is actually a very common process. If you've actually been to your dentist's office and you've gotten a ceramic crown or anything, you've actually not witnessed, but you've actually handled a sintered item. So, like, for example, you get the dentists often have sintering ovens. If they have a lab, they definitely will. If they don't have a lab, they may not. But basically, well, they may for sanitization purposes potentially. But anyway, but yeah, so sintering is pretty fun. You also can use sintering in 3D printing of metal, because in part of the 3-step process is 3D print with a PLA metal mix, melt it in an acid bath, sinter, finish. But I'm happy Twitch let me chat this time, because last time it wanted me to confirm my email, which was weird.
The particles fuse into a sheet. It's slow, it's offline, and it poses a major limiting factor in the manufacturability of solid-state batteries. Palladium chose differently from day one. Their ceramic separator is made by a wet film coating, the same process used for cathode and anode coating in any conventional battery factory. You mix the ceramic into a slurry, you coat it onto a moving roll of metal foil, and dry it.
So this is the input anode on the current collector and the anode. And if you look right there, that is the separator, the solid-state separator applied.
That is so crazy.
One of the key breakthroughs that allows Prologium to produce batteries roll to roll at large scale, a process we saw firsthand. And looking at this factory, you can see how much thought was put on speed.
So this is anode,
Yeah, and
ceramic,
cathode.
cathode.
Wow.
Different
Yeah.
requirements,
Yeah,
right?
Okay. Temperature.
Most of this line you see here are heaters because the faster that roll is moving, the less time you have to dry it. And
That
the
makes
result is
sense.
absolutely amazing. Prologium's pilot ceramic
Been content for a long time. I have my A6 in electrical building, my electrical clips. Nice.
5 meters per minute, nearly an
Jeez.
any sintering approach could even imagine reaching. Then there's drying.
This oven behind me is 24 meters long, but by the time this roll has snaked through, this entire roll has snaked through, it'll have traveled 240 meters up and down.
Woo!
Drying stage. And because of this system, the speed that it goes through,
That's insane.
and some of the other secret sauce they have,
A quarter of a kilometer.
down in about 8 minutes, what normally takes most battery manufacturers 8 hours. And this is critical. At this point, when the roll comes out of this, there's no moisture because it's going into
We're watching a video about solid state battery production.
can't have any moisture left after this step.
Even the cell housing is different. Where conventional
Is this a replicatable machine or one-of-kind machine? Like, I think this is replicatable,
Prologium prints,
but the process is proprietary.
using a proprietary silicon-based material that they call logithium.
You can kind of see it's this outer boundary. It acts as a couple of things. It's an adhesive layer. It helps them to stack these cells together. So this would be the cathode.
Oh, they are definitely very ahead. Like, so us ahead. It's insane. Like, this is wrinkling my brain. Like, I never thought a lot of these things were even possible. Like, I thought, like, the things they're talking about and the capabilities that this battery has, I thought would only exist in a sci-fi movie and would never actually exist in reality. Like, this just to me feels like it defies physics what they're able to achieve.
Acts as an additional separator at the edges of every stacked cell, preventing short circuits both during production and through the life of the battery. Patented all the way back in 2010, and that same
Jeez.
with an additional edge separator has
We've had this
across
for 15 years.
before most people even were
16 years.
solid state batteries. Now this might be a part of their technology that
I had just graduated high school. Solid state batteries were not even in, my mindset at that time. Think about all the projects you can make with these batteries. Oh yeah, indeed. Think about how great it would be to safely solar power your entire house with solid state batteries and not have to worry about your house going up in flames because your solar powered batteries caught on fire.
I kind of didn't appreciate until I saw it in person. Think screen printing on a shirt. That's kind of what it reminded me of. But they're doing this on a roll-to-roll process. Conventional battery production steps like electrolyte injection, right, where you get the pouch and then you squeeze the liquid in, vacuum impregnation, second formation cycles are completely eliminated. The dry room footprint shrinks dramatically. And as amazing as the access for all the safety tests and propane torch tests were, this right here might be even more amazing.
Yeah, he's totally right, because you can shrink the footprint of an entire battery factory because of the way that everything is laid out. That's... jeez.
This is the answer every battery analyst has been asking for 20 years.
Well, they said it's been around for more than a decade.
Complex, brittle ceramics on a roll-to-roll process, the stuff that makes solid-state batteries so appealing and possibly do it economically at scale. And while we've covered so many companies that make a lot of noise, Prologium is already producing nearly a gigawatt hour a year with plans to scale that to 3 here in Taiwan.
The project growth strategy is not only development of better batteries. Our goal is to build up the next generation battery platform that can be mass produced at a scale and offer the affordable cost and provide into the many different markets.
Oh, and they're also planning their next factory in Dunkirk, France. And then there's the number one comment I've gotten over the past 2 months or so, which is weighing the cell and getting actual testing for the watt hour per kilogram energy density. Well, I did that too. The cell that I'm holding here was verified by the German testing body TÜV Rheinland, but I actually got to test it myself.
All right, so we've shown you some safety, we've shown you how it's made, but the question you're probably wondering, and I always have been as well, is what about the energy density? Well, you need two things for that. You got to figure out how much this weighs, weigh the cell, and second, we have to test to see how much energy it can store and how much we can get back out. So let's actually weigh this. 97.5.
1.7 kilos, roughly.
1.75 kilograms. Okay, so they're doing the energy density test to see just how much energy they can put in and get back out of these cells. So we'll go look at the monitor and see how they fare. We started with a cell here with a voltage starting at 4.1 volts and ran the test until the voltage dropped to about 2 volts.
Oh, wow, it gets very low.
612.37 watt hours.
Wow.
12.37. Which gives us a energy density of 360.748 watt hours per kilogram. That is a number you've probably been thinking about. I know I have. And with validation and testing, we can actually show you something that you've probably been thinking. That number is the highest I've seen. Amazing.
That's what I was blown away, because let me see. Lithium ion watt hour density. It is 150 to 350 watt hours per kilogram by weight. So this is kilo per kilo on par with the best lithium ions. This is looking like this should be the replacement for lithium ion battery technologies.
So now this is the volumetric. Okay, so volumetric energy density of 898 watt hours per liter. Also the highest I've ever seen.
So how did they hit that number? Well, two design choices working together. A nickel-rich cathode called NCM955 that's 90% nickel, 5% cobalt, 5% manganese, the most aggressive nickel-rich chemistry at scale, paired with a silicon composite anode that stores roughly 5 times more lithium per gram than graphite. For example, the best cells in EVs today are around 270 watt hours per kilogram. Prologium solid-state cells beat that by 20 to 30%. And the roadmap goes even further. They've already reached 380 plus watt hours per kilogram. And it's manufacturing ready, not a lab experiment. With a full lithium metal anode on the roadmap.
And we're still like in the infancy of a lot of this technology, so it could be pushed even further. Who knows? We could even get to 500 watt hour performance levels. That could be insane.
They could push that number even higher. So what does it mean for EVs? Well, 30% more range from the same battery weight, or 30% lighter battery packs, depending on how you look at it. What about cycle life? While the cells were still being tested at scale by automotive OEMs as we speak, Prologium told us that they comfortably exceed standard automotive requirements matching cells today.
We believe that only the balance and the practical next generation battery solution can truly support the development of the industry. Such a solution must combine the high safety, the high energy density, and stronger performance, affordable cost, and scalable mass production capability.
All of these numbers that we've shown are third-party verified. I quickly realized why Prologium was so transparent with me. It's because they've done so much third-party validation already. Seriously, it was enough to make my head spin.
Yeah, like seriously, out of all the solid-state battery, things I've been hearing about and reading, this is the first time I've seen a company be like completely transparent and be like, yeah, here's everything. Here's it all out. You need anything else? Because everyone else, like, what was it, that donut battery and all that? It was, like, always cagey, these specific controlled, weird circumstances they tested it under, and it was just like, dude, just go bananas.
Met with Prologium in Taiwan, I didn't really even have a definition for what a solid-state battery actually was. And now I've tested it, I've punctured it, I've cut it in half, I've weighed it and measured it. And aside from working with EV manufacturers, they're also working with key players in other emerging markets too, and a French gigafactory breaking ground for the European market. It turns out 2 decades of doing the hard work, stacking innovations on top of each other, and quietly being brilliant really pays off. I've never worked with a more transparent company, I've never had more access, and I've never had more of my questions answered. And I've just been absolutely blown away. One other thing I learned doing this video was I saw this bag of potato chips sitting on a lot of the machines in the factories and in the labs. And I asked him, like, what is this? So if you look right there, that translates to well-behaved. This is a popular children's snack. And the idea is that this is made for good boys and girls. And so it's a Taiwanese tradition to put this on machinery to make sure that the machines are well-behaved and work well.
Oh, that's cute.
Maybe it's a secret to all the genius that happens here in Taiwan. So if it's good enough for Taiwan and Prologium, it's good enough for us. We're going to put this on our hardware as well. So what do you think? How amazing has this been? And what questions do you have for the team? If you think we've earned it, burn that like button and puncture that subscribe button so you don't miss our future deep dive videos. Huge thanks to Prologium. Thank you for all the time and coordination and for giving us so much access. This was one of our favorite videos we've ever made. All right, I'm Ricky.
That was a great video. But yeah. Oh, that's really cool to see that the battery tech and everything is starting to take off. But yeah, anyway, it's getting late, everybody. Make sure, if you haven't already, to follow me on all of my socials. The links are in the bio if you don't see them, to join the Discord, join the Matrix, follow me on all of my socials, YouTube, Twitch, Kick, TikTok, Blue Sky, Mastodon, Instagram, PixelFed, all the platforms, links in bio. Make sure to follow, join the Discord, join the Matrix. Like I said, we have a great community. I love you all. Stay safe. Happy hacking. If you're over on Twitch, stick around for the raid. Otherwise, I will see you all tomorrow. We made up for yesterday's stream today, because yesterday was Memorial Day. I had some stuff to do and lost track of time. But yeah, tomorrow is the next scheduled stream around 7:30 p.m. Eastern Standard Time. Maybe we'll do some more streams to catch up on the content I got to review. And then, of course, Sundays, Gaming on Linux night. Hopefully, NVIDIA will fix that driver issue, and then we'll do Forza 6 on Linux. Otherwise, we still got to finish up Pragmata. And, of course, I got Gears of War Remastered or whatever it was, and a few other games. But, love you all. Stay safe. Happy hacking. Stick around for the raid. And see you later.